Hi, this is Dr. Adam Weiss, and we are going to talk about educational research. In particular, we're going to talk about today quantitative research and what makes it unique compared to other forms of research, such as qualitative research or mixed methods research. So, there are a couple key elements of quantitative research. First of all, in terms of purpose, quantitative research focuses on either a descriptive purpose or an explanatory purpose. So a descriptive purpose would be just trying to describe numerically a phenomenon, like what percentage of teachers have a master's degree. Explanatory would be research that tries to explain the relationship between two variables, explain why something occurred. So, for example, an explanatory form of quantitative research might be what is the relationship between years of experience and student performance on years of experience of a teacher and their students' performance on a standardized test. So there's two variables, years of experience of the teacher and students' performance on a standardized test, and then they're trying to explain, the study is trying to explain what is the relationship between the two. Another key element of quantitative research, just like the name implies, is that it's going to have some type of numbers. There's some kind of numerical analysis. Sometimes you'll see that quantitative research will employ surveys that have a scale, like a Likert scale. So, like maybe, for example, if you have the scale or the range, least likely to most likely. Either way, you can convert those values into numbers. So somewhere in the process of your analysis during your quantitative paper, you're going to have your variable values converted into numbers. So your data will eventually become converted into numbers. Quantitative research also collects data in a variety of ways. In my class, if you're one of the students that's taking my educational research class, we'll be primarily using survey data to collect our data. But other types of quantitative research are experimental research, and so this would be the kind of research, for example, that you see in the natural sciences like physics, chemistry, biology. But also this would be the kind of research you might see for pharmaceutical research on whether or not a drug is effective or not, or there could even be experimental research on whether or not a particular intervention, it could be an educational intervention or a counseling intervention, what is the influence of that intervention on the population that receives that intervention. And then another type of quantitative research could be where you use data that's collected by other researchers, like existing governmental data from the census, for example, or from maybe student achievement data from the state, and then you are using quantitative methods to analyze it. So that would be a form of unobtrusive research, because you yourself as a researcher are not collecting the data personally, and you're also not interfering with someone by asking them to participate in the study, because the data has already been collected by somebody else. So another important element of quantitative research is that the researcher at the beginning of their study, probably after their introduction section and right after they've discussed their research questions and their theoretical framework, which if you've seen my other videos, then you'll know about those two things. And if you haven't, then please look at my other videos on research. But after the researcher has provided their research question and their theoretical theoretical framework, in quantitative research, the researcher then poses a hypothesis of what they expect to find in their study. And then later, at the end of their paper, in their discussion section, they're going to reflect upon whether or not their hypothesis was supported, or whether or not their hypothesis needs to be rejected. So in terms of hypothesis and determining whether or not it's supported, you need to, you're not necessarily, you have to prove, or you have to support that your hypothesis is the best explanation for why this phenomenon occurred. And to be specific, you're also explaining how there's not another explanation that could better explain why this happened. So the null hypothesis, the opposite of the hypothesis, cannot be true. And if this sounds a little complicated, that's okay. For my Intro to Educational Research class, we're doing an introductory class, and so we don't go too much into specifics about hypothesis versus null hypothesis. But if you do take doctoral courses, they will go into more detail on that. But I just wanted to introduce those ideas. So your hypothesis, you're not necessarily proving it to be true. You're not saying that your hypothesis was proven in your research, but rather you're just trying to prove that there's no other better explanation for why this event occurred, or this relationship happened. So explanatory quantitative research also has an independent variable and a dependent variable. So first of all, variables are things that change in a study. So a variable could be any kind of characteristic that differs between groups of people. It could be income level, years of experience, level of satisfaction, level of confidence, maybe it could be like health factors, like someone's BMI or their cholesterol levels. So all of those are variables that could change between people. It depends on the person. So there's two different types of variables that you need in explanatory quantitative research. You need an independent variable and a dependent variable. And we'll talk about both of them in future slides, but just to give kind of an introduction, the independent variable is the variable that's in charge, that influences the other variable. The independent variable works on its own, and it's basically in charge of the relationship. It's affecting whether or not the relationship occurs and to what extent. And then the dependent variable, kind of like the name implies, is dependent upon how the independent variable works. So if the dependent variable is another term for it, could be the resulting or the outcome variable. Its outcome is based off of how the independent variable functions in a quantitative research study. So getting into that, let's talk about explanatory quantitative research. And so we've already kind of talked about variables, but variables are characteristics of a person or group, and that can change between people, and it can change throughout observations, throughout an experiment, or throughout a study. And so in explanatory quantitative research, like we mentioned before, you will make sure that you have at least an independent variable and then a dependent variable, and we'll talk more about them in a second. But one thing to note also is throughout your study, when you have variables, things that change or things that are may shift in size or value, you need to make sure that you define those variables. We call that in research operational definitions. So for things like, I give an example of if you are studying college persistence, that's something you're interested in studying in your research, you have to define what is persistence, because that is a variable that can change between student to student. And what one person might consider persistence, or might consider a measurement of college persistence, might be different than another researchers. So some researchers might define persistence as just continuing to the next semester after their first semester of college. But other researchers might define persistence as their likelihood or their ability to graduate within 4 years. Or another researcher might even call persistence the ability to acquire a full credit load each semester. So it's important you define your variables for your particular study. So let's go into the different types of variables. We've already mentioned a little bit, but just to review, an independent variable is the variable that's kind of in charge, the one that's inspiring the change between the relationship in the two variables. Another term that we sometimes use to describe this independent variable is the predictor variable. Based off the independent variable, we're seeing if we can predict what kind of change we would see in the dependent variable. And so the dependent variable, like I mentioned earlier, is the variable that changes based on how the independent variable functions. And so sometimes we call it the outcome variable. So the outcome of the relationship occurs based on the independent variable. There's another type of variable. There's actually other types of variables, but one type of variable that we'll talk about in this slide is mediator variables. So mediator variables stand in between the independent and dependent variables, and they help transfer the effect from the independent variable to the dependent variable. And so let's look at an example. I think that'll help solidify this in a more concrete way. So, for example, what if you're studying the relationship between participation in an after-school tutoring program and student test scores? So those are your two variables. So the amount of participation in the school tutoring program, and then the second variable is the change in students' test scores, or students' test scores at the end of the study. So in that situation, the independent variable would be student participation in the after-school program. That is not affected by other variables. That's on its own. Students choose to participate in the study or participate in the after-school program, and that's its own variable on its own. And whether or not students participate in that after-school program will influence, or we're trying to see whether or not it will influence students' eventual test scores at the end of the intervention. So the dependent variable is students' test scores. So students' test scores, we would say, are being influenced by whether or not students participated in this after-school tutoring program. And then the mediator variable that kind of helps transmit or kind of helps the relationship occur between the independent variable and the dependent variable could be which teacher students receive in that after-school program, or the setting of the after-school program, what school it was set in. So another type of variable that's kind of related to these three variables we talked about earlier are moderating variables. So moderating variables are similar to an intervening or mediator variable in that it's not directly the independent variable or the dependent variable, But a moderating variable instead affects the strength or the level of influence that the independent variable has on the dependent variable. So it helps modify how much, what type of relationship they have, and to what effect they interact with each other, and to what strength or the amount of interaction they have. So let's look at another example. So if you were studying the relationship between students' socioeconomic status and school attendance rates in a district, your independent variable, the one that's we think that is predicting the other, that's determining the other, would be students' socioeconomic status. That's not going to be changed by whether or not students attend school in that district. A student's socioeconomic status will be consistent in the sense that that will be determined before we measure the relationship between the two. On the other hand, students' attendance could be determined by or influenced by that student's socioeconomic status. So the dependent variable, what we're measuring to see the outcome, is what is the outcome on students' attendance averages. And then the mediator variable between those two variables would be the particular school. The particular school is the one that's helping transmit if there is a relationship between a student's socioeconomic status and their likelihood to attend school, or their average days of attendance. And then the moderating variable, which is like an outside variable that's not the independent variable or the dependent variable, but does affect the strength of those variables, could be parents' level of education. So you might have a student that might be low income, but the parents are maybe in graduate school. Let's say they're in medical school, or maybe they're very highly educated, and for some reason or another the family's low income, but the parents could still be very adamant about education. And so that could influence whether or not children are likely to attend, or children attend the school district, is the parents' level of education. So even though we're not directly measuring that, that is having some influence on the strength of the relationship between socioeconomic status and free or reduced lunch. So another thing we can think about when we consider variables is how we're going to measure them. So we also can define variables or classify variables on how they're measured. So a variable can be considered or measured nominal. A variable can be considered a nominal variable, or can be considered a variable that's measured nominally or categorically if the variable can be grouped into particular categories or groups. So it can be classified into particular categories or groups. We would call those nominal or categorical variables. So an example of this would be if you were measuring either the independent or the dependent variable nominally, you could be measuring variables such as political party. That's grouping someone based off of a certain classification or group status. Race is a nominal variable. Gender, or type of car a person drives. All of those things can be classified in particular categories, and there's not a particular order or numerical quantity assigned to each of them. Ordinal variables would be variables that you can rank and you can order them appropriately based off their rank. So, and they have some kind of position and an order in terms of least to greatest based off that position. So, the most traditional probably ordinal variable that we consider as young people is maybe position in a race, or position in a line, or in the class rank. All of those things have some particular order, In the case of class rank, often in Texas, it's used by first is the best, and afterwards the ranks that follow are they could still be desirable, but they're less than the first. Income is another type of ordinal variable. You could rank people based off of their income level from low, medium, or high. Difficulty level is also a form of ordinal variable where you could rank something from easy, moderate, to hard. Now notice in these examples that ordinal variable does not necessarily have to be an exact formula or exact way to classify one thing versus another. It just has to be a way to put something in order from least to greatest. So we don't necessarily know we might not necessarily know the difference between something that's easy and something that's moderate in difficulty might be shorter or smaller than the difference between something that's moderate in difficulty and something that's really, really hard or difficult. However, even though the difference between the two values might not be uniform, we can still provide a rank from least to greatest. And the reason why I gave that explanation is because interval variables are a form of ordinal variables, but what's special about them is that the space between each value, each rank, is going to be equal in distance. So a good example of this would be a temperature scale, either Celsius or Fahrenheit. So on a temperature scale, we have lower temperatures versus higher temperatures, and we can rank temperatures from least to greatest, or colder to warmer. But the space between each temperature point from 0 to 1 degrees or 1 degree to 2 degrees is the same. It's the same value between 0 degrees to 1 degrees, from 1 degrees to 2 degrees, and 2 degrees to 3 degrees. So each spot on that line, if you plot it as like a number line, has equal value, an equal interval between each value. A ratio scale, on the other hand, is a variable that is, it's similar to interval variables in that it is ordinal. You can make an order from least to greatest. It also has an equal space between each value. So it kind of has the qualities of ordinal variables and interval variables. But ratio scales are unique in that they actually have a true zero. So there's actually a minimum value, a lowest value. So a good example of a ratio scale could be age or years of experience. And that scale, there is a true minimum value, 0. You can't have lower than 0 years of age, or you can't have lower than 0 years of experience. Absolutely no experience. And then if you have your values, the whole values of years from 1 year to 2 year is the same. The distance between 1 year to 2 year is the same as the distance between year 29 and year 30. So each year is the same distance, 365 days, and I think it's like a quarter. So another thing we like to talk about in explanatory studies, and this is just to give you an overview, and just when you're writing your papers to be cognizant of the type of languages or language you're using, the type of vocabulary you're using to describe the relationship in your findings section, is the topic of correlation versus causation. So first let's describe what is correlation versus causation. So correlation just means that the two values there is some pattern to how the two variables are influencing the other. So so an example might be a correlation, and I gave an example here on this slide. So they found out, before I give this kind of silly example, I'll give a more real world example. So something that could be correlated is that the number of sunny days in a region could be correlated with the likelihood that a region buys ice cream, the number of ice cream cones consumed in a region. So there could be a correlation. We could see that in general, regions that are sunnier have more ice cream consumed. And that could just be people's, there could be some explanation, there could be some, slight relationship, but there could be also other explanations, right? There could be other reasons. So maybe areas that are sunnier also might have better economies because they can have a longer growing season. Or maybe areas that are sunnier have people who are perhaps more active because they're outside. And so people who are more active might be more likely to pass ice cream vendors. I'm not sure. But there could be other factors to explain that correlation. Causation, on the other hand, says that that one variable, the independent variable, caused the other. So, for sure, the reason why something occurred was because of the independent variable. So it's a direct cause and effect relationship. So we have to be careful because most of the time in our research, we can only prove correlation. So I'll give you an example. So they did a study on global temperatures and the number of pirates. And what they found was there actually was a correlation that the more days, I'm going to move in a little bit just to read it more closely, but the number, and actually I read it wrong. So it's the number of pirates is the independent variable, and then the dependent variable is the average temperature. So on this slide, they found that for some reason, when the number of pirates went up, the number of the global average temperature went up. And later you'll learn in another presentation that I have on quantitative data analysis that this would be called a positive relationship. The independent variable is increasing, pirates, and the dependent variable, global temperature, is also increasing. So they're both increasing, or they're both moving in the same direction. It's kind of like a positive relationship in terms of a friendship or romantic relationship. If you're both moving in the same direction, if you're both growing together, then it's positive. But so in this case, they found this, but this is just a correlation. It happens to be something that's interesting, but we can't say that because there's more pirates that the pirates change the temperatures. No, there's no way to explain that. It's just a coincidence. It's just a correlation. So, in order to prove causation, it's much more complicated. So most of the time, many of you, when you're writing your papers in your findings section, and then in your discussion section towards the end of the paper, when you're interpreting your results from your quantitative research study, you're going to try to use the words correlation and refrain from using causation. And there's a couple of reasons why. Because to say something is there's causation, you have to have three existing factors. First, there has to be a correlation between the two. So there has to be a pattern. Second, you have to demonstrate that there was a time order component that existed and that the independent variable occurred before the dependent variable occurred. Or the independent variables or the intervention, which is from the independent variable, occurred before you measured the value, the outcome, the dependent variable, which was the outcome of the intervention. And then another thing, the third factor that you need to consider is there could be no other better explanation, or there could be no other explanation for why the two variables are interacting this way. or there could be no other better explanation to explain why, in the case of the global pirates and global temperatures, why temperatures have been increasing over time. Well, probably a better explanation would be maybe global warming, carbon emissions, things like that. But the number of pirates would not be the strongest explanation. So as you can see, that could only, in that example that was kind of extreme but funny, there's only a correlation, not a causation. So for my class, if you're in my educational research class, you will see that since we're not doing a longitudinal study with a pre-test and a post-test, and we're not doing an intervention over time and then measuring whether that intervention occurred, we can't say causation for our research. We're not doing an experimental research where there's a experimental group that receives the intervention and a control group that stays the same and doesn't receive an intervention. And we're not comparing the two over time. We're just looking at one particular point in a cross-sectional study. We're measuring two variables. So we can say there's correlation, but not causation. So it's interesting to see, but we still can't prove causation. Maybe future research could do that, and that's something you could mention in your conclusion section, or even earlier in your paper, in your discussion section if you wanted to, that you can prove correlation and causation would be interesting to study. But for our research, we can't prove causation. We can only say there's some correlation. So when you're using, the terms you use are very important. So using correlate, or there's a relationship between the two, but saying that one causes the other, we can't do that in our class. Only really experimental researchers can really do that effectively. All right. So that's the end of the presentation. Thank you so much. These are some of the unique qualities of quantitative research. Please stay tuned for another video where I describe what is the difference between qualitative research papers or articles versus quantitative research articles. So how are the two different and when it comes to writing each type? And there are some small differences between the two, and so that will be an upcoming presentation. All right, thank you.